Welcome to Sleep Science World. Pull up a chair and take a deep breath. Let us leave the day behind. Let science guide you toward peaceful dreams. Have a wonderful night.
The universe is 93 billion light-years wide. And yet, right now, as you settle into wherever you are resting, every single atom in your body was forged somewhere inside it. The calcium in your bones came from ancient stars that exploded before our sun was born. The iron in your blood was scattered across the galaxy by dying giants billions of years before Earth existed. You are not just looking at the universe tonight, you are made of it. Welcome to Sleepy Science World. Tonight, we are going on a long, slow, deeply peaceful journey through 100 extraordinary sleep science facts about the universe, the grandest, strangest, most beautiful thing that has ever existed. We will travel from the very first moment of time, through the lives and deaths of stars, across galaxies beyond counting, to the furthest edges of what we can observe, and right to the most fascinating questions science is still working to answer. There is nothing you need to do, no place to be. Let your body relax completely, let your breathing slow, and let the quiet wonders of the cosmos drift gently through your mind as you find your way towards sleep. We have 5 chapters waiting for you tonight and 100 facts that will carry you from the beginning of everything to the very edge of the unknown. Let us begin at the only place a story of the universe can truly begin, the very first moment. Chapter 1. The First Moment. The Birth of the Universe. Facts 1 to 20. Everything began, not with a sound, not with a flash of light, but with something so small, so incomprehensibly dense that all of space, all of time, all of matter and energy, everything that has ever existed or ever will, was contained within it. Close your eyes. Let that settle. Everything you have ever known came from that single, perfect, infinite beginning. Fact 1. The universe began approximately 13.8 billion years ago in an event known as the Big Bang. But it wasn't an explosion in space, it was an explosion of space itself. Space did not exist before this moment. Time did not exist. There was no before. There was simply the beginning, and then the extraordinary unfolding that followed. Fact 2. In the first tiny fraction of a second after the Big Bang, a period known as the Planck epoch, lasting only 10 to the power of -43 seconds, the universe was smaller than an atom and hotter than any temperature that currently exists anywhere in the cosmos. Physics, as we understand it, simply cannot describe what happened during this moment. It is the edge of what we know. Fact 3. Within the first second of the universe's existence, the 4 fundamental forces, gravity, electromagnetism, the strong nuclear force, and the weak nuclear force, separated from what scientists believe was originally a single unified force. Each split carried the universe a step further from its origin and a step closer to the cosmos we now inhabit. Fact 4. The very first particles to form were quarks, the building blocks of protons and neutrons, appearing within the first microsecond. These quarks were so hot and so energetic that they could not yet combine into anything larger. The universe was a dense, unimaginably hot soup of particles and radiation, filling all of space equally in every direction. Fact 5. After approximately 3 minutes, the universe had cooled enough for protons and neutrons to combine into the first atomic nuclei, a process called Big Bang nucleosynthesis. In those few minutes, nearly all of the hydrogen and helium in the universe was created. Every hydrogen atom in every ocean, on every planet, around every star, traces its origin to those first 3 extraordinary minutes. Fact 6. For the first 330,000 years of its existence, the universe was so hot and dense that light could not travel freely. Photons, particles of light, were constantly scattered by free electrons, making the entire universe opaque, like the inside of a dense fog. Nothing could be seen because there was nothing yet capable of seeing through it.
Fact 7. Then, 380,000 years after the Big Bang, the universe cooled enough for electrons to combine with nuclei and form the first neutral atoms. Suddenly, light was free to travel. The universe became transparent for the first time. That ancient light, stretched and cooled over billions of years of cosmic expansion, still fills the universe today. We call it the cosmic microwave background. Fact 8. The cosmic microwave background, or CMB, is one of the most remarkable discoveries in the history of science. It is the afterglow of the early universe, a faint signal of microwave radiation coming equally from every direction in the sky. It was accidentally discovered in 1965 by 2 radio astronomers who initially thought the static in their antenna was caused by pigeon droppings. It earned them a Nobel Prize. Fact 9. The CMB is almost perfectly uniform. The temperature of this ancient light is the same in every direction to within 1 part in 100,000. But those tiny fluctuations, those whisper-thin variations in temperature, are the seeds of everything that followed. Slightly denser regions of the early universe became the first galaxies, the first stars, the first planets, and eventually us. Fact 10. After the first atoms formed, the universe entered a period scientists call the Cosmic Dark Ages, a span of roughly 150 to 800 million years, during which there were no stars and no light. The universe existed in complete, vast, patient darkness, slowly allowing gravity to gather hydrogen and helium into the structures that would eventually ignite. Fact 11. The first stars, known as population 3 stars, formed roughly 100 to 200 million years after the Big Bang. These were extraordinary objects. Some estimates suggest they were hundreds of times more massive than our Sun, burning furiously and briefly. They lived fast and died violently, seeding the cosmos with the first heavy elements and lighting up the universe for the first time. Fact 12. The death of those first stars was one of the most important events in cosmic history. They exploded as supernovae, scattering carbon, oxygen, silicon, iron, and dozens of other elements into the surrounding gas. These elements would become the raw material of everything that came after, including every rock, every ocean, every living cell on Earth. Fact 13. The universe is expanding. Not just expanding, accelerating. Every galaxy is moving away from every other galaxy, and the further away a galaxy is, the faster it appears to recede. This was discovered in 1929 by Edwin Hubble, who noticed that the light from distant galaxies was systematically shifted toward the red end of the spectrum, stretched by the expansion of space itself. Fact 14. The force driving this accelerating expansion is one of the deepest mysteries in all of science. Scientists call it dark energy. It appears to be a property of space itself, a kind of pressure inherent in the vacuum of the universe that pushes outward, counteracting gravity on the largest scales. Nobody knows what dark energy truly is. It makes up approximately 68% of the total energy content of the universe. Fact 15. The observable universe, the sphere of space from which light has had enough time to reach us in 13.8 billion years, is approximately 93 billion light-years in diameter, but the universe almost certainly extends far beyond what we can observe. How far it goes, and whether it is infinite or finite, is not yet known. If the universe is infinite in extent, then everything that can possibly happen, every configuration of matter, every arrangement of particles, happens infinitely many times. Somewhere in an unimaginably distant part of an infinite universe, there may be a region indistinguishable from ours, with a planet indistinguishable from Earth, and someone indistinguishable from you, drifting towards sleep while listening to sleep science facts about the universe. Fact 18. The universe contains an estimated 2 trillion galaxies, a number revised upward dramatically in 2016, when astronomers used new techniques to count galaxies in the deepest images ever taken of space. 2 trillion galaxies, each containing hundreds of billions of stars, each star potentially orbited by planets. The number of individual worlds that might exist in the universe is so large it has no intuitive meaning. The Hubble Ultra Deep Field Image, a photograph taken by the Hubble Space Telescope over 11 days of accumulated exposure, pointing to a tiny patch of sky that appeared completely empty to the naked eye, revealed approximately 10,000 galaxies. That one small patch of apparently empty darkness contained 10,000 entire galaxies, each with hundreds of billions of stars. Every speck of empty sky contains multitudes.
Fact 19. The universe was not always accelerating in its expansion. For the first several billion years, gravity was slowing the expansion down. Then, approximately 5 billion years ago, the universe crossed a threshold. Dark energy became dominant enough to overcome gravity on cosmic scales, and the expansion began to accelerate. The universe shifted from decelerating to accelerating just as our solar system was beginning to form. Fact 20. The ultimate fate of the universe remains one of the great open questions in cosmology. If dark energy continues to grow stronger, the universe may end in what physicists call the Big Rip, a scenario in which the expansion eventually tears apart galaxies, then solar systems, then planets, then atoms themselves. If dark energy remains constant, the universe will simply continue expanding forever, growing darker and colder until the last star burns out, and even black holes slowly evaporate into nothing. Either way, there is no need to worry tonight. We have an estimated 100 trillion years before the last star dies. Rest easy. Chapter 2. Stars, the cosmic forges of the universe. Facts 21 to 40. We are going to slow down even further now. Settle deeper into wherever you are resting. Stars are the universe's most beautiful engines. They create light, create heat, create the elements of life itself, and they do it for billions of years with a patience and constancy that is humbling beyond words. Let the soft weight of starlight rest on you tonight. Fact 21. Stars form inside vast clouds of gas and dust called nebulae. Over millions of years, gravity slowly pulls the gas inward. As the cloud collapses, it heats up. At the center, the temperature and pressure build until hydrogen atoms begin to fuse together and a star is born. That moment of ignition, happening in perfect silence across the universe, is one of the most fundamental events in all of nature. Fact 22. Our Sun is a star of beautifully ordinary character, a yellow dwarf, roughly middle-aged at 4.5 billion years old, with another 5 billion years or so left to burn. Every second, it converts approximately 600 million tons of hydrogen into helium through nuclear fusion.
releasing the energy that warms every living thing on Earth, every second, without pause, for 4.5 billion years. The light reaching your skin on a warm day left the sun approximately 8 minutes and 20 seconds ago, but the energy in that light took a far longer journey. It was generated in the sun's core and took between 10,000 and 100,000 years to slowly work its way outward through the dense solar interior before finally escaping into space and making its 8-minute crossing to Earth. Fact 24. The most massive stars in the universe are extraordinary, almost frightening in their scale. Stars like R136A1, located in the Large Magellanic Cloud, are estimated to contain more than 250 times the mass of our Sun. They burn so furiously that they consume their fuel in just a few million years, brief lives by cosmic standards, and die in catastrophic explosions that briefly outshine entire galaxies. Fact 25. The smallest stars are red dwarfs, tiny, cool, and almost impossibly long-lived. A red dwarf with a fraction of the Sun's mass burns so slowly and efficiently that it may continue fusing hydrogen for 10 trillion years or more, nearly 1,000 times the current age of the universe. The universe is too young for any red dwarf to have died of old age yet. They are all still burning, patient and persistent in the dark. Fact 26. Stars do not simply shine, they pulse, they spin, they emit great storms of charged particles called stellar winds. They occasionally erupt in massive flares, and they carry powerful magnetic fields that shape the space around them. Our own Sun, for all its apparent serenity, is a churning, dynamic, magnificently violent place. The sunspots visible on its surface are regions of intense magnetic activity, each one larger than the entire planet Earth. The surface of the Sun, the part we see, is called the photosphere and has a temperature of approximately 5,500 degrees Celsius. But just above it, the corona, the Sun's outer atmosphere, reaches temperatures of 1 to 3 million degrees. Why the corona is so much hotter than the surface below it is one of solar science's longest-standing mysteries. The heat flows the wrong way, and we do not fully understand why. Fact 28. Binary star systems where two stars orbit each other are astonishingly common. More than half of all Sun-like stars in the Milky Way are thought to be part of binary or multiple star systems. Our single Sun may actually be the exception rather than the rule. Some systems have 3, 4, or even 6 stars all bound together gravitationally, tracing complex, intricate orbits around each other over the centuries. Fact 30. When a star like our Sun exhausts its hydrogen fuel after billions of years, it swells into a red giant, expanding to hundreds of times its original size. Our own Sun will eventually expand to roughly the orbit of Earth, engulfing Mercury, Venus, and possibly Earth itself. But this will not happen for another 5 billion years. Tonight, the Sun is precisely where it needs to be, and so are you. Fact 30. After its red giant phase, a Sun-like star sheds its outer layers into space, creating a beautiful expanding shell of glowing gas called a planetary nebula, one of the most visually stunning objects in the cosmos. The name is misleading. These structures have nothing to do with planets. They were named by early astronomers who thought they resembled planets through small telescopes. At the center, the star's core remains as a white dwarf. Fact 31. A white dwarf is one of the densest objects in the universe that is not a neutron star or black hole. A white dwarf the mass of the Sun is compressed into an object roughly the size of Earth.
A teaspoon of white dwarf material would weigh approximately 5 tons on Earth's surface. These remnants cool slowly over billions of years, eventually fading into cold, dark objects called black dwarfs, though the universe is not yet old enough for any to have formed. Fact 32. Massive stars end their lives far more dramatically. When a star many times more massive than the Sun runs out of fuel, its iron core collapses in less than a second, an implosion so violent and sudden that the infalling material bounces off the newly formed neutron star at the center and triggers a catastrophic explosion. In that moment, the dying star releases more energy than the Sun will emit in its entire 10-year lifetime. Fact 34. A supernova explosion briefly outshines an entire galaxy of hundreds of billions of stars. In 1987, a supernova visible to the naked eye blazed in the Large Magellanic Cloud, a nearby companion galaxy, and was studied in unprecedented detail. Neutrinos from the explosion passed through the Earth in a burst that lasted just 12 seconds. 10 billion of those neutrinos passed through every square centimetre of your body. You felt nothing. Fact 35. The elements heavier than iron, gold, silver, platinum, uranium, and dozens of others, cannot be made by ordinary stellar fusion. They require the extreme conditions of a supernova, or the even more extreme environment of two neutron stars colliding. Every gold ring ever worn, every silver coin ever spent, traces its origin to the violent death of massive stars billions of years ago. Wealth, in the most literal sense, is made of ancient catastrophe. Fact 36. In 2017, astronomers detected gravitational waves from two neutron stars merging, an event called a kilonova. Telescopes around the world and in space simultaneously observed the collision. The explosion was found to have produced enormous quantities of heavy elements, gold, platinum, and strontium among them. In a fraction of a second, more gold was created than the Earth contains in total. The universe does not do things modestly. Fact 37. Neutron stars are among the most extreme objects in existence. The entire mass of a star greater than our Sun is compressed into a sphere roughly 20 kilometers across, smaller than a city. The density is so extreme that a single teaspoon of neutron star material would weigh approximately 4 billion tons. The gravity at the surface is 200 billion times stronger than Earth's, and yet neutron stars spin. Fact 38. Some neutron stars rotate hundreds of times per second, emitting beams of radio waves from their magnetic poles. From Earth, these beams sweep past us like cosmic lighthouses, producing extraordinarily precise regular pulses. We call them pulsars. The first pulsar discovered in 1967 pulsed so precisely, 1.33 seconds between each pulse, never varying, that the astronomers who found it briefly wondered if it might be an artificial signal. They nicknamed it LGM1 for Little Green Men. Fact 39. Stars are not scattered randomly across the universe. They cluster into galaxies, which cluster into superclusters, which form part of vast cosmic web of filaments and voids. The universe on the largest scales resembles a three-dimensional spider web, long strands of matter separated by enormous empty voids. The structure emerged naturally from those tiny fluctuations in the early universe, amplified by gravity over billions of years. Fact 40. The Milky Way contains between 200 billion and 400 billion stars. It's a barred spiral galaxy approximately 100,000 light-years across and about 1,000 light-years thick at our location. Our solar system is situated about 26,000 light-years from the galactic center, roughly 2/3 of the way out along one of the galaxy's spiral arms. a quiet, unremarkable neighborhood, perfectly suited for the emergence of life. Fact 41. Every star you can see with the naked eye on a clear night is located within our own galaxy, and most are within a few thousand light-years of Earth. The entire Milky Way, with its hundreds of billions of stars, appears to us as a faint band of light stretching across the sky, and only when we are far from city lights can we truly appreciate its beauty. Light pollution has stolen this sight from most of humanity, but it is still there, always, waiting in the dark above us.
Chapter 3. Galaxies, Islands of Stars in the Cosmic Ocean. We zoom out now, impossibly far out, beyond our solar system, beyond our nearest stellar neighbors, beyond even the Milky Way itself, into a universe filled with galaxies beyond counting, each one a city of stars, each one a world of its own. Let this immensity settle gently around you, like the quiet dark of a clear night. Fact 41. Galaxies come in a remarkable variety of shapes. Spiral galaxies like the Milky Way and Andromeda have graceful rotating arms wound around a central bulge. Elliptical galaxies are smooth, featureless, egg-shaped collections of older stars with little ongoing star formation. Irregular galaxies have no particular shape at all, usually the result of gravitational encounters with other galaxies that have disturbed their structure. The universe is gloriously varied in its architecture. Fact 42. The largest galaxies in the known universe are giant ellipticals called CD galaxies, found at the centers of massive galaxy clusters. These monsters can contain tens of trillions of stars and span millions of light years. They grew so enormous by cannibalizing smaller galaxies over billions of years, pulling them in with their overwhelming gravity and absorbing their stars, one galaxy at a time, across cosmic history. Fact 43. The smallest galaxies are dwarf galaxies, faint, irregular collections of perhaps a few 100 million stars. The Milky Way is surrounded by dozens of dwarf satellite galaxies, including the large and small Magellanic Clouds, visible from the southern hemisphere as faint patches of light. These small companions orbit our galaxy the way moons orbit planets, slowly being stretched and pulled apart by our galaxy's gravity over billions of years. Fact 44. Dark matter, an invisible, unknown substance that does not emit or absorb light, makes up approximately 27% of the universe's total energy content. We cannot see it, but we know it is there because of its gravitational influence on visible matter. Without dark matter, galaxies would not hold together. The stars in a spiral galaxy's outer regions orbit too fast to be explained by the visible matter alone. Something unseen must be providing additional gravitational pull. Fact 45. The nature of dark matter is one of the most pressing unsolved problems in physics. Decades of experiments have failed to directly detect it, though its gravitational effects are unmistakable. Leading candidates include weakly interacting massive particles, WIMPs, and axions, but none have been confirmed. We know more about the cause of distant stars than we do about what dark matter is. The universe has been keeping this secret for a very long time. Fact 46. Galaxies are not stationary. They move through space, pulled by gravity, interacting and sometimes colliding with one another. Galaxy collisions are actually common on cosmic timescales, and they unfold with extraordinary slowness over hundreds of millions of years. When galaxies collide, the stars themselves almost never hit each other. The spaces between stars are simply too vast. Instead, the galaxies pass through each other, their shapes distorted by tidal forces before eventually merging. Fact 47. The Antennae galaxies, two spiral galaxies currently in the process of colliding, located about 45 million light-years away, are one of the most beautiful objects in the sky.
The collision has triggered an extraordinary burst of star formation, with thousands of new star clusters blazing to life in the disturbed gas between the two galaxies. Destruction and creation happening simultaneously across millions of light years. Fact 48. Our own Milky Way is on a collision course with the Andromeda Galaxy, our nearest large galactic neighbour, located approximately 2.5 million light-years away. The two galaxies are approaching each other at roughly 110 kilometers per second and will begin to merge in approximately 4.5 billion years. The resulting collision will unfold over another few billion years, eventually producing a single large elliptical galaxy that astronomers have already nicknamed Milkdromeda. Fact 49. Despite the dramatic nature of galaxy collisions, our solar system is likely to survive the Milky Way-Andromeda merger largely intact. The chances of our Sun coming dangerously close to another star during the merger are vanishingly small. We may be flung to a new location in the merged galaxy, and the night sky will transform beyond recognition, but our descendants billions of years from now may watch the most spectacular light show in the history of the solar system.
Fact 50. Galaxies are grouped into clusters, which are themselves grouped into superclusters. Our Milky Way is part of the Local Group, a collection of approximately 80 galaxies dominated by the Milky Way and Andromeda. The Local Group is part of the Virgo supercluster, which is itself part of a vast superstructure called Laniakea, a Hawaiian word meaning immeasurable heaven, a supercluster containing roughly 100,000 galaxies spanning 520 million light-years. Fact 51. Beyond superclusters, the largest structures in the universe are vast cosmic filaments, streams of galaxies and dark matter stretching hundreds of millions of light-years through space. Between these filaments lie enormous voids, regions of space that are almost completely empty, containing very few galaxies. The largest known void, the Boots void, spans approximately 330 million light-years. If our Milky Way were inside the Boots void, we would not have discovered any other galaxies until the 1950s. Fact 52. The most energetic events ever observed in the universe are gamma-ray bursts, brief flashes of gamma radiation so powerful that they briefly outshine the rest of the observable universe combined. They come in two varieties: short bursts lasting less than 2 seconds, caused by neutron star mergers, and long bursts lasting minutes or hours, caused by the collapse of massive stars. A gamma-ray burst pointed at Earth from within a few thousand light-years could sterilize the side of the planet facing it. Fact 53. Quasars, the brilliantly luminous cores of active galaxies powered by supermassive black holes consuming enormous amounts of material, are among the most distant objects we can observe. The light from the most distant quasars left its source when the universe was less than 1 billion years old. We are seeing these objects as they appeared in the early universe, their light making a journey of over 13 billion years to reach our telescopes tonight. Fact 54. The most luminous quasar known, J0529-4351, was confirmed in 2024 to be the brightest object ever discovered in the universe. It releases energy equivalent to 500 trillion times the luminosity of our Sun. The black hole at its center consumes the equivalent of 1 sun every single day. It sits roughly 12 billion light-years away, a beacon of the young universe blazing at an intensity that strains comprehension. Fact 55. Gravitational lensing, the bending of light around massive objects predicted by Einstein, allows astronomers to use galaxies and galaxy clusters as natural telescopes. When a distant galaxy aligns behind a massive galaxy cluster, the cluster's gravity bends and amplifies the distant galaxy's light, sometimes producing multiple images or dramatic arc-shaped distortions. This effect has allowed us to observe galaxies so distant they would otherwise be far too faint to see. Fact 56. The James Webb Telescope, launched on Christmas Day 2021 and operational since 2022, has revolutionized our view of the early universe. It has detected galaxies from when the universe was just 320 million years old, far more developed than models predicted they should be at that early stage. These early, surprisingly mature galaxies are challenging our understanding of how galaxies form and evolve, suggesting the universe assembled its large-scale structures faster than we thought. Fact 57. Some of the most intriguing structures found by the James Webb Telescope are compact reddish objects, now nicknamed little red dots, dense galaxies from the early universe that appear remarkably bright given their age. They may represent a previously unknown population of galaxies from the cosmic dawn, and their nature is still being debated among astronomers. The universe is still surprising us, even after decades of looking. Fact 58. Radio galaxies, galaxies that emit enormous amounts of radio waves, typically powered by active supermassive black holes, can produce jets of plasma stretching millions of light-years into space. The radio galaxy Hercules A has jets extending roughly 1.5 million light-years in both directions from its center, carving enormous cavities in the surrounding hot gas of the galaxy cluster in which it sits. The scale of the influence of a single black hole, expressed across millions of light-years, is staggering. Fact 59. For most of the 20th century, astronomers debated whether the spiral nebulae they observed were structures within the Milky Way or separate galaxies, island universes in their own right, unimaginably distant. The great debate between astronomers Harlow Shapley and Heber Curtis in 1920 encapsulates this uncertainty. Edwin Hubble settled the question in 1924 by measuring the distance to the Andromeda Galaxy, demonstrating it lay far beyond our own. The universe became 1 billion times larger overnight. Fact 60. We now know that our observable universe contains approximately 2 trillion galaxies. The total number of stars across all those galaxies is estimated to be around 10 to the power of 24. That is a 1 followed by 24 zeros. This number exceeds the estimated number of grains of sand on all Earth's beaches and deserts combined by a factor of roughly 10,000, and every one of those stars may have planets. The universe is almost unimaginably full of worlds. Chapter 4. Deep Mysteries. Dark Matter, Dark Energy, and the Unknown Universe. Facts 61 to 80. We are going even deeper now into the parts of the universe that science has identified but not yet explained. The unknown is not frightening here. It is beautiful. It is the reason there is always more to discover, always more to wonder about, always more reasons to stay curious. Let these mysteries rest lightly on your mind, like stars reflecting on still water. Fact 61. The ordinary matter that makes up stars, planets, gas, dust, and every living thing, everything we can see and touch and measure directly, constitutes only about 5% of the total energy content of the universe. The remaining 95% is dark matter and dark energy, completely unknown in its fundamental nature, yet responsible for shaping the large-scale structure of everything that exists. Fact 62. Dark matter was first inferred by Swiss astronomer Fritz Zwicky in 1933,
when he measured the velocities of galaxies in the Coma cluster and found they were moving far too fast to be held together by the visible matter alone. Something extra, something unseen, must be providing additional gravitational glue. He called it dunkel materia, dark matter. His colleagues largely dismissed the idea. He was right, and it took nearly 4 decades for the scientific community to take the problem seriously. Fact 63. Vera Rubin and her colleague Kent Ford provided the most compelling early evidence for dark matter in the 1970s through precise measurements of galaxy rotation curves. Stars in the outer regions of spiral galaxies orbit at speeds that should, by Newton's gravity, decline with distance from the center, just as the outer planets of our solar system orbit more slowly than the inner ones. They do not. They orbit at nearly constant speed, implying a vast halo of invisible matter surrounding every galaxy. Fact 64. Despite decades of searching, dark matter particles have never been directly detected. Experiments deep underground, shielded from cosmic rays and other interference, have watched enormous tanks of ultra-pure liquid xenon for years, waiting for a single dark matter particle to collide with a xenon nucleus. Nothing. The Milky Way is believed to be embedded in a vast halo of dark matter, yet not a single particle has betrayed itself in any detector. Whatever it is, it interacts very weakly with ordinary matter indeed. Fact 65. Alternative theories attempt to explain the effects attributed to dark matter without invoking new particles. Modified Newtonian dynamics, or MOND, proposes that gravity behaves differently at very low accelerations, doing away with the need for dark matter in many galaxy rotation curves. However, no modification of gravity has successfully explained all the evidence for dark matter, including the Bullet Cluster, 2 galaxy clusters that collided, with their hot gas and dark matter halos separating in ways that perfectly match the dark matter prediction. Fact 67. Dark energy was discovered in 1998 when 2 independent teams of astronomers, the Supernova Cosmology Project and the High Z Supernova Search Team, measured the distances and recessional velocities of distant supernovae, expecting to find that the universe's expansion was slowing down under gravity. Instead, they found it was accelerating. The universe is not just expanding, it is accelerating. Both teams shared the Nobel Prize in Physics in 2011 for what has been called the most surprising discovery in the history of cosmology. Fact 68. The Hubble tension is a significant and growing problem in modern cosmology. 2 different methods of measuring the universe's expansion rate, one based on the cosmic microwave background and one based on observations of nearby galaxies and supernovae, give different answers that cannot be reconciled within current theory. Either one of the measurements is wrong, or our standard model of cosmology is missing something fundamental. Physicists are paying close attention. Fact 69. The multiverse hypothesis, the idea that our universe is one of many, emerges naturally from several independent areas of physics. Inflationary cosmology, which describes a period of exponential expansion in the universe's first fraction of a second, predicts that many separate universe-like regions may have formed in an eternal, ever-inflating background. String theory suggests a landscape of perhaps 10 to the power of 500 possible universes, each with different physical constants. Whether the multiverse is testable or even science at all is deeply debated.
Fact 70. The anthropic principle observes that the physical constants of our universe appear to be remarkably finely tuned for the existence of complex matter and life. If the strength of gravity, the mass of the electron, or the value of the cosmological constant differed by tiny amounts, stars could not form, atoms could not exist, or the universe would have collapsed or expanded too quickly for structures to emerge. Whether this fine-tuning demands an explanation, and if so, what kind, is one of the deepest questions in all of philosophy and science. Fact 72. Cosmic inflation, the theory that the universe underwent a period of exponential expansion in the first tiny fraction of a second after the Big Bang, was proposed by physicist Alan Guth in 1980. It elegantly solves several puzzling features of the universe: why it is so flat, why the CMB temperature is so uniform across regions that should never have been in contact, and why no magnetic monopoles have been detected. The theory makes specific, testable predictions, many of which have been confirmed. Fact 73. Quantum mechanics, the physics of the very small, and general relativity, the physics of the very large, are the two most successful and most precisely tested theories in the history of science. They are also fundamentally incompatible with each other. Attempts to combine them into a single theory of quantum gravity have occupied some of the greatest minds in physics for nearly a century, and a complete, satisfying solution has not yet been found. The universe is telling us something profound, and we are still learning to hear it. Fact 74. Loop quantum gravity, one approach to quantum gravity, suggests that space itself is not continuous, but is made of discrete, quantized units, tiny loops of gravitational field, with a minimum size of the Planck length, approximately 10 to the power of -35 meters. At this scale, the smooth space-time of general relativity breaks down and gives way to a granular, foamy structure. Space in this picture is not a smooth canvas, but a fine-grained fabric. Fact 75. String theory, another approach, proposes that the fundamental constituents of nature are not point-like particles, but tiny, vibrating, one-dimensional strings of energy. Different vibrational modes of the string correspond to different particles. The theory requires the existence of extra spatial dimensions beyond the three we experience, curled up so tightly they are invisible at any accessible energy scale. String theory is mathematically rich and internally consistent, but has not yet made unique, testable, experimental predictions. Fact 76. The holographic principle, a profound conjecture arising from the study of black holes and string theory, suggests that all the information needed to describe a three-dimensional volume of space is encoded on its two-dimensional boundary, like a hologram. Applied to the universe as a whole, it raises the remarkable possibility that the three-dimensional world we inhabit is, in some deep mathematical sense, a projection of information on a distant two-dimensional surface. Reality, at its deepest level, may be nothing like it appears. Fact 77. The Fermi paradox asks a haunting question. Given the age of the universe, the vast number of stars and planets, and the apparent ability for life to emerge given the right conditions, where is everybody? The silence of the cosmos, the absence of any detected signal or sign of other civilizations, is deeply puzzling. Solutions range from the sobering, intelligent life is extremely rare or inevitably destroys itself, to the hopeful, we simply haven't looked hard enough or are not yet advanced enough to detect the signals that exist. Fact 78. The search for extraterrestrial intelligence, SETI, has been ongoing since 1960, when Frank Drake pointed a radio telescope at two nearby sun-like stars and listened for signals. In 1977, a radio telescope in Ohio detected an unusual narrow-band signal that astronomer Jerry Emmons circled on the printout and annotated with the word "Wow." It remains the most intriguing candidate signal ever detected, never repeated, never explained. The universe has not yet answered. Fact 79. The discovery of exoplanets, planets orbiting other stars, has transformed our understanding of the universe's potential for life. Before 1995, not a single planet beyond our solar system had been confirmed. Today, more than 5,000 are known, and the total number in the Milky Way alone is estimated to be in the hundreds of billions. Many orbit within their star's habitable zone, the range of distances at which liquid water could exist on a planet's surface. The conditions for life appear to be common. Fact 80. The James Webb Space Telescope has begun analysing the atmospheres of exoplanets, searching for chemical signatures, biosignatures, that might indicate the presence of life. In 2023, tantalizing hints of potential biosignatures were detected in the atmosphere of the planet K2-18b, a sub-Neptune world in the habitable zone of a red dwarf star 120 light-years away. The results are preliminary and disputed, but they represent the beginning of what may become one of the most important scientific investigations in human history.
Chapter 5. The Human and the Cosmos. Science, Discovery, and Our Place in the Universe. Facts 81 to 100. We return now slowly and gently from the far edges of the cosmos and the deepest mysteries of physics, back to the human story, the extraordinary tale of how a species that has been looking at the night sky for a few 100,000 years managed to understand in just a few centuries of science the age and shape and history of the entire universe. Take a slow breath. These final facts are for you. Fact 81. Modern astronomy began in earnest on the night of January 7, 1610, when Galileo Galilei turned a telescope skyward and observed 4 small points of light moving around Jupiter over successive nights. He realized they were moons, objects orbiting a body other than Earth. This single observation fundamentally challenged the idea that everything in the heavens revolved around Earth and set in motion a revolution in our understanding of our place in the cosmos. Fact 82. Isaac Newton, born in the same year Galileo died, synthesized the observations of Copernicus, Kepler, and Galileo into a unified mathematical theory of gravity that described both the fall of an apple and the orbit of the moon with a single equation. For over 2 centuries, Newtonian gravity described the universe with extraordinary precision. It was only at the extremes, near massive objects at high velocities, that its limitations became apparent, and Einstein's relativity was required. Fact 84. Albert Einstein developed his general theory of relativity in November 1915 after a decade of deep thought. Within months, Karl Schwarzschild had used it to describe what we now call black holes. Within a few years, it had predicted the bending of light around the Sun, confirmed during a solar eclipse in 1919, making Einstein the most famous scientist in the world. Relativity has since been confirmed to extraordinary precision in countless experiments, including the GPS satellites that depend on relativistic corrections to give accurate positions. Fact 85. The Voyager 1 spacecraft, launched in 1977, is the most distant human-made object ever created. As of 2024, it is more than 24 billion kilometers from Earth, so far that a radio signal traveling at the speed of light takes over 22 hours to reach it. It is now in interstellar space beyond the influence of the Sun's solar wind, drifting through the space between the stars. It carries a golden record containing sounds and images from Earth, a message to whoever might someday find it. Fact 87. Carl Sagan, who championed the Voyager Golden Record, requested that NASA command Voyager 1 to turn its camera back toward the inner solar system in 1990. The resulting image shows Earth as a tiny pale blue dot, a fraction of a pixel in size, against the darkness of space. Sagan's reflection on that image remains one of the most profound statements ever made about the human condition. Every king and peasant, every act of cruelty and compassion, every hero and coward, every creator and destroyer, every saint and sinner who ever lived on a mote of dust suspended in a sunbeam. Fact 87. The International Space Station has been continuously inhabited since November 2000, making it the longest continuously crewed space habitat in history. It orbits Earth at an altitude of approximately 400 kilometers, completing one orbit every 90 minutes. From its windows, astronauts witness 16 sunrises and 16 sunsets every single day. Many describe the experience of seeing Earth from orbit as profoundly life-changing, a cognitive shift in perspective known as the overview effect. Fact 88. The Apollo missions between 1969 and 1972 brought back approximately 382 kilograms of lunar rocks and soil, samples that have been studied by scientists worldwide for 50 years and continue to yield new insights. The Moon's surface has barely changed in billions of years, preserving a record of the early solar system that Earth's active geology has long since erased. Every lunar rock is a message in a bottle from the birth of the worlds. Fact 89. The Square Kilometre Array, SKA, is a radio telescope currently under construction in South Africa and Australia, which, when complete, will be the largest scientific instrument ever built. With a total collecting area of 1 square kilometre, it will be able to survey the sky thousands of times faster than any current telescope, search for radio signals from other civilizations, probe the nature of dark energy, and observe hydrogen from the cosmic dark ages before the first stars formed. It will listen to frequencies the universe has been broadcasting since before life existed on Earth. Fact 90. The Nancy Grace Roman Space Telescope, named for NASA's first chief of astronomy, scheduled for launch in the coming years, will survey the universe with a field of view 100 times larger than Hubble's, building maps of dark matter distribution through gravitational lensing and searching for signs of dark energy's influence on cosmic structure. It is named for a woman who fought within NASA in the 1960s to make the Hubble Space Telescope a reality. Her patience and persistence span decades. Fact 91. The field of astrobiology, the scientific study of the origin, evolution, and distribution of life in the universe, has grown dramatically over the past 30 decades. Scientists now know that life on Earth can survive in environments once thought impossible. Boiling hydrothermal vents on the ocean floor, highly acidic hot springs, Antarctic ice sheets, highly radioactive environments, and the vacuum of space for extended periods. The definition of habitable has expanded enormously. Life, it turns out, is much harder to extinguish than we thought. Fact 92. Saturn's moon Enceladus, discovered by the Cassini spacecraft to have a global subsurface ocean beneath its icy crust, jets water vapor and ice particles into space through cracks at its south pole. The water sampled by Cassini contains hydrogen, silica, organic molecules, and salt, conditions strikingly similar to deep-sea hydrothermal vents on Earth, where some of the most extremophilic life on our planet thrives. Enceladus may be, in the view of many astrobiologists, the most promising place to search for life in the solar system. Fact 93. Jupiter's moon Europa, with its global subsurface ocean beneath a thick ice shell, has been a priority target in the search for extraterrestrial life for decades. NASA's Europa Clipper mission, launched in October 2024, will make dozens of close flybys of Europa starting around 2030, analysing the moon's surface, ocean, and potential plume activity. If life exists in Europa's ocean, it has been isolated from the rest of the solar system for billions of years, evolving in its own dark, pressurized world. Fact 94. Titan, Saturn's largest moon, is one of the most Earth-like places in the solar system, and yet profoundly alien. It has a dense nitrogen atmosphere, weather systems, river valleys, lakes, and seas. But the liquid in Titan's lakes is not water, it is liquid methane and ethane, pooling at a temperature of -179 degrees Celsius. Scientists have proposed that exotic methane-based life might exist there, using chemical reactions in liquid methane instead of water. It would be life as we have never imagined it. Fact 95. The Perseverance rover, currently operating on Mars, is the most sophisticated instrument ever sent to another planet. It is collecting rock samples that will be returned to Earth by a future mission, the first time material from Mars will have been brought back for laboratory analysis. Among its experiments is an instrument called MOXIE, which has successfully produced small amounts of oxygen from the Martian atmosphere, a proof of concept for future human life support on the red planet. Fact 96. The human brain, that 3-pound universe contained within each of our skulls, processes reality through approximately 86 billion neurons, each connected to thousands of others, forming a network of roughly 100 trillion synaptic connections. The complexity of the human brain, by some estimates, rivals the complexity of the observable universe at the scale of galaxies. The organ with which we contemplate the cosmos is itself a cosmos, a universe looking at itself and wondering what it is. Fact 97. You share approximately 60% of your DNA with a banana, 98.7% with chimpanzees, and 100% with every other human being alive today. All life on Earth shares a common ancestor, a single-celled organism that lived approximately 3.8 billion years ago. That first cell, somehow arising in the chemistry of the early Earth, gave rise to every form of life that has ever existed on this planet. Every bacterium, every plant, every insect, every whale, and every human being who has ever looked up at the night sky and wondered. Fact 98. The atoms in your body have been part of stars, nebulae, comets, asteroids, oceans, ancient forests, and countless other life forms before they became part of you. The oxygen you breathe was produced by photosynthetic organisms over billions of years and gradually accumulated in our atmosphere. The carbon in your cells was fused in stellar cores. The The water in your body has been cycling through Earth's oceans, atmosphere, glaciers, and living things for as long as water has existed on this planet. You are, in the deepest sense, made of the universe's history. Fact 99. In the cosmic calendar proposed by Carl Sagan, a metaphor in which the entire history of the universe is compressed into a single year, the Big Bang occurs on January 1st. Our solar system forms on September 2nd. The first life on Earth appears around September 21. Dinosaurs appear on December 26th and are gone by December 29th. All of recorded human history, every empire, every war, every great work of art and science and love occurs in the last 14 seconds of December 31. We are very new here, and we are learning very fast. And perhaps the most remarkable fact of all, the one that quietly underlies every other fact in this entire journey, is this: the universe did not need to be beautiful. It did not need to produce stars that glow with colors discernible to eyes. It did not need to create a planet where liquid water flows and life emerged, and creatures who could look upward and ask why. It did not need to be comprehensible to minds like ours, and yet it is. The universe is not only stranger than we imagined, it is more beautiful than we had any right to expect. And tonight, in the quiet and the dark, you are part of it. You always have been.
And so we come to the end of our journey. 100 sleep science facts, carrying us from the very first moment of time, through the birth and death of stars, across billions of galaxies, into the deepest mysteries of dark matter and quantum gravity, through the human story of discovery, and finally, here, to this quiet moment, to you. The universe is 13.8 billion years old. It contains 2 trillion galaxies. It is filled with mysteries that may never be fully solved, with beauty that exceeds anything we have words for, with a history so vast and strange that spending a lifetime studying it would leave most of it untouched. And you are made of it. Every atom, every breath, every thought drifting through your mind right now as you settle towards sleep. There is nothing you need to do, nothing to solve or figure out or hold on to. The universe has been here for nearly 14 billion years. It will continue long after every star is burned out and every galaxy has gone dark. Tonight, in this small, warm moment, you are exactly where you're supposed to be. A tiny, conscious, briefly awake part of something infinite and astonishing, resting. Thank you for spending this time with Sleepy Science World. If the universe carried you somewhere peaceful tonight, please subscribe and come back next week for another slow journey through the wonders of sleep science. Sleep well, dream of stars, and remember, you are the universe, awake and wondering. Good night.